Students, last class I have discussed about motion in a straight line. What is the motion? Any body or any object change its position with respect to surrounding with a time is called motion. There are three types of motion: translator motion, rotational motion and oscillation. And so one dimension motion, two dimension motion and three dimension motion. If a body moving along a straight line, that is a one dimension motion. When a body moving in a plane, that is a two dimension motion. When a body moving in a space is called a three dimension motion. Now today class, motion in relative terms. Motion in relative terms, when a body moving along a straight line, that is a one dimension motion. When a body moving in a plane, that is a two dimension motion. The motion of a body with respect to the coordinate system, coordinates here OX, OY is the coordinate system. The motion of a body with respect to the coordinate system is called a frames of reference. Now when a body moving along straight line, you calculate, some important definitions for the first one is a distance traveled. Distance traveled or path length. Distance traveled, displacement, speed, velocity and acceleration. These are important definitions for motion in relative terms. The first one is a distance traveled and path length. So distance traveled, now there are 2 points. Here A is one point, B is another point. When a body or object or car or any vehicle moving from A to B, covering a distance taken for time t second. Motion means the body change its position with the time. So now A and B have two fixed points or two fixed places, two fixed points. The length of the actual path travelled by the body is called a distance travelled. Now define distance travelled. The length of the actual path travelled by the body is called a distance travelled or path length path length. Distance travelled a path length. Distance travelled is a scalar quantity. So there are two types of physical quantity. One is the scalar quantity, another vector quantity. Scalar quantity. Scalar quantity. A quantity which has only magnitude but no direction is called scalar quantity. Vector quantity. Vector. A quantity which has both magnitude as well as direction is called a vector quantity. So now here distance travelled is the scalar quantity. The length of the actual path travelled by a body is called a distance travelled or a path length. Distance travelled is a scalar quantity. What is a scalar quantity? A quantity which has only magnitude but no direction. So now distance travelled is a scalar quantity. Distance travelled cannot be negative for moving body. So after a body covering certain distance, so that length taken to be positive. So this is a very important point here. The distance travelled cannot be negative for a moving body. So this is a definition of distance travelled. The length of the actual path travelled by the body is called a distance travelled. It is a scalar quantity. So the distance travelled cannot be negative for a moving body. So after displacement. Second one, displacement. Displacement means, second one, motion in relative terms of displacement. The change in position of your body in a particular direction is called displacement. Now example here, when a body or object move from A to B, here A to B. If a body move from A to B, Then the body or a vehicle moving from B to C. So students, so now here you see that A to B. If a body moving from where to where? A to B. Then B to C. Now join this line AC. Now AC represents displacement. So one more definition. If a displacement is the shortest distance between initial and final position of the body. So define a displacement, the change in position of a body in a particular direction is called a displacement. How can we measure displacement? The displacement is measured by distance along a straight line joining initial and final position of the body. The example here, if a body starting position at A moves to A to B, then the body moves from B to C. So AC represents displacement. So displacement, it is a vector quantity because a quantity which has magnitude as well as direction. A quantity which requires both magnitude and direction is called a vector quantity. So I will repeat one more time. Displacement, the change in position of a body in a particular direction is called a displacement. Or one more definition, the shortest distance between initial and final position of the body is called a displacement. Now in the diagram, the body starting initially at A, move to B, then B to C. AC is represented by displacement. Displacement is a vector quantity. Now students, now a 2-mark question. Write any two differences between distance travelled or path length and displacement. It is very important point for examination. A 2-mark question. Distinguish between distance travelled and displacement. Now you are arranging two columns. The first column distance travelled. Second column displacement. So the first point, it is the length of the actual path. Length of the actual path. Now here, these are 2 points are there, A and B. The length of the actual path travelled by the body is called a distance travelled. So the first one here, it is the length of the actual path. Displacement, it is change in position. The body changing its particular direction is called a displacement. So now the first point, it is the length of the actual path. It is the change in position. Now second point, it depends on the path. It depends on the length of path. It is independent path. So independent path means the displacement means the shortest distance between initial and final position. Initial, the body move at A to B. So B to C. So AC is the displacement. So this is the independent path. Sometime maybe, so this distance may be, so here. So that is independent path. So now second point, it depends on the path. It is independent path. So last one, it is a scalar quantity. Displacement is a vector quantity. So in a scalar quantity, a quantity which has only magnitude but no direction. Vector quantity, a quantity which requires both magnitude and direction is called a vector quantity. So students, this is a 2-mark question. Write any two difference between distance travelled and displacement. So now here, observe here, it is the length of the actual path. It is a change in position, displacement. It depends on the path. It is independent path. It is a scalar quantity. It is a vector quantity. Friends, now speed. First one, distance travelled. Second point, displacement. Now speed. So what is meaning of speed? The time rate of covering a distance by an object is called a speed. The time rate of covering a distance by an object is called a speed. Now example for students, two vehicles are moving on the road. You observe two vehicles. The one vehicle may be which maintains speed maybe 70 kilometers speed. Second vehicle may be maintains 60 kilometers speed. So the time rate of covering a distance by an object is called a speed. Now speed equals distance traveled by time taken. Distance traveled. Distance traveled by time taken. Distance traveled by time taken. Speed equals distance traveled by time taken. Define a speed. The rate of covering a distance by an object is called a speed. Now here speed equals distance traveled by time taken. Speed is measured by distance traveled for unit time. Distance traveled for unit time. And one more point here, speed is a scalar quantity. It has only magnitude but no direction. Speed is a scalar quantity. And second one, the SI unit of speed is meter per second. Meter per second. So now here the SI unit of distance meter. The SI unit of time second. So now here meter by second. So this one written as m 1 by s. 1 by s written as s power minus 1. 1 by s. Here the SI unit of distance travel is a meter. The SI unit of time is a second. So meter per second. So this term written as m s power minus 1. The SI unit of distance speed is meter per second. The SI unit of speed is a meter per second. So now your speed equal to distance traveled by time taken. Speed is a scalar quantity. The SI unit of speed is meter per second. Speed is measured by distance traveled per unit time. Average speed, the total distance traveled by total time taken. Average speed equal to total distance traveled by total time taken. So this is the average speed. So students, here first you know the definition of the speed. The time rate of covering a distance by an object is called a speed. Speed equal to distance traveled by time taken. Speed is a scalar quantity. The SI unit of speed is meter per second. Average speed equal to total distance traveled by total time taken. Now velocity. So last one speed. The time rate of covering a distance by an object is called speed. Now velocity. The rate of change of displacement is called velocity. The rate of change of displacement is called velocity. The mathematical expression of differential equation. So velocity v equals dx by dt. dx by dt. dx by dt is the rate of change of displacement. So within 1 second, the body, how much position will be changed. Then the rate of change of displacement is called velocity. V equal to dx by dt. So friends, you carefully observe this mathematical term. V equal to dx by dt. This is the mathematical differential formula. So now V equal to dx by dt. dx by dt is nothing but the rate of change of displacement is called velocity. So V equal to dx by dt. Now velocity equals displacement by time taken. Displacement by time taken. Displacement by time taken. So velocity equal to displacement by time taken. Define velocity, the rate of change of displacement. The rate of change of displacement is called velocity. Mathematical formula V equal to dx by dt. So dx by dt, this mathematical symbol represent the rate of change of displacement. This is called velocity. Velocity equal to displacement by time taken. So now your velocity is a vector quantity. Velocity is a vector quantity. A quantity which has both magnitude and direction is called vector quantity. So velocity is a vector quantity. Speed is a scalar quantity. And the SI unit of velocity is meter per second. SI unit of velocity is a meter per second. So here the SI unit of displacement meter. SI unit of time second. So m by s, m divided by s. 1 by s written as s power minus 1. Therefore, the SI unit of velocity is meter per second. Whatever velocity, average velocity, instantaneous velocity, orbital velocity, escape velocity, wave velocity, unit is same, meter per second. So velocity means the rate of change of displacement is called velocity. Velocity equal to displacement by time taken. Velocity is a vector quantity. SI unit of velocity is meter per second. So now differences between speed and velocity. Speed and velocity. Students, here difference between speed and velocity. Write any two differences between speed and velocity. Now first column here speed, second column velocity. This is a 2-mark question. So difference between or distinct between speed and velocity. Speed equals distance traveled by time taken. Is very important point. Speed equal to distance traveled by time taken. Here velocity equal to displacement by time taken. Displacement by time taken. This is the first point. Second one, it is the rate of change of position. Speed, the rate of change of position. Here the rate of change of displacement. Second point, here speed is the rate of change of position. Velocity is the rate of change of displacement. So it is the rate of change of position. Here it is the rate of change of displacement. And last point, speed is a scalar quantity. So it is a scalar quantity. Velocity, it is a vector quantity. So now 3 points are there in examination. In a 2-mark question is very important. Write any two differences between speed and velocity. So now we have looked at here. Speed equal to distance traveled by time taken. Velocity equal to displacement by time taken. Speed is the rate of change of position. Velocity is the rate of change of displacement. Speed is a scalar quantity and velocity is a vector quantity. So now here the last point, acceleration. First one, distance traveled, displacement, speed, velocity. Now acceleration. The rate of change of velocity is called acceleration. When acceleration act in the vehicle, maybe your bike or scooty or car, you maintain different velocity, different speed. Example, your vehicle, you maintain speed 40 km, 50 km speed, 60, 70, 80. This range of speed, velocity will be changed. The change in velocity by time taken, that is called acceleration. That means the rate of change of velocity is called acceleration. Acceleration symbol small a. Acceleration symbol small a, not capital A, and do not mention any other symbols. So now your acceleration symbol A equals dV by dt. dV by dt is very important mathematical formula. It is a mathematical differential formula, dV by dt. Now I am telling, so statement definitions here, the rate of change of velocity is called acceleration. Example, your vehicle within 1 second, how much velocity will be changed. So already I told that your vehicle may be maintained 40 km speed, 50 km speed, 60, 70. So this order, what happened? Velocity will be changed. So change acceleration equal to change in velocity. Change in velocity. Change in velocity by time taken. change in velocity by time taken. Friends, so you know the definitions, how to understanding the concept of acceleration. Acceleration equal to change in velocity by time taken. So vehicle which maintain different speed, different velocity. So acceleration equal to change in velocity by time taken. So within 1 second, the vehicle, how much velocity will be changed? That the rate of change of velocity is called acceleration. The mathematical formula A equal to dv by dt. So this mathematical equation dv by dt is a rate of change of velocity. So dv by dt is the rate of change of velocity is called acceleration. Acceleration symbol you indicate or represent small a, not capital A, and do not mention any other symbol. So A equal to dv by dt, the rate of change of velocity is called acceleration. And acceleration is a vector quantity because it has both magnitude and direction. Therefore, acceleration is a vector quantity. What is the essence of acceleration? What is the essence of acceleration? Now, your velocity unit meter per second. Your time unit what? Yes, per second. Velocity, the essence of velocity is a meter per second. Time, the essence of time is second. So now here, so m. So s4 minus 1. 1 by s also written as s4 minus 1. So now here m power m s4 minus 2. In your mathematics, a to the power of n into a to the power of m equal to a to the power of m plus n. So a to the power of m plus n. So now here what? S4 minus 1 minus 1. So S4 minus 1 minus 1 what? S4 minus 2. So now here the essence of acceleration is meter per square second. Friends, the essence of acceleration is a meter per second. So once again repeat. Define acceleration. The rate of change of velocity is called acceleration. So how do you know concept this one? So you observe your vehicle which maintain different speed moving on the road. The vehicle moving on the road with different speed. So maybe 40, 50, 60. The velocity will be changed. Change in velocity by time taken is called acceleration. The mathematical formula A equal to dv by dt. Acceleration is a vector quantity. The essence of acceleration is meter per square second. And when is acceleration is positive? So when the acceleration is positive, velocity of the body increase. When the acceleration is negative, the velocity of the body decrease. The negative acceleration is called a retardation. The negative acceleration, for example, this is the graph. Acceleration versus time. So now this graph here negative acceleration. This negative acceleration is called a retardation. So when velocity of the body increase, so acceleration is also increase. When velocity of the body decrease, acceleration decrease. The negative acceleration is called a retardation.